180 way too soon, and somehow they want to stick the 180 in the table. Don't touch it. So now, after you get this, you're ready to touch it. So if you add this up, the formula weight of this is what? 30. Well, is that equal to 180? No, it's not nearly as big. When this rolls up, it's either going to be equal to or a little bit less. It's never going to be greater. It's going to be less or equal. Okay, so here's what we say, and this is where there were a number of questions. 30 times what gives us 180? 6. So then we have to take that. How do I alter that, Sarah?
You multiply each subscript, I guess, by 6.
Perfect. Glucose. Now, did everybody survive? First, everybody survived to here? Okay, then when we get here, that's when we use the 180. And some folks made it to here and then couldn't remember what to do next. So 30 times what will jack it up to be the full 180. You multiply by 6. Okay, everybody? All right, then let's take a look. The next kind of problem, the major problems in this chapter. Okay, it's the grams to moles to molecules business that we've done and we have reviewed. The next major was composition that we did last time, and now coming up with empirical formulas and molecular formulas. Those are the biggies. Now, these two things are just kind of extra tack-ons that you can occasionally see. So let's take a look. And on this problem, 219. 219, I work differently than the textbook does because I think the textbook makes it harder than it needs to be. I have this compound. This is ammonium dichromate. This is really an interesting compound. One thing you can do with it, and we used to do it all the time until we realized how toxic chromium is, you put a little piece of magnesium in the top. You build a little hill of it, you put some magnesium in the top, and you torch the magnesium. Remember burning magnesium? Okay, that will set this stuff off. It will decompose, and you get this volcano effect. It's really, really cool. We might do it someday down under the hood so we don't have stuff toxic material spraying on us. That in the old days, nobody knew it was toxic, and we used to do it all the time. So ammonium dichromate makes a king volcano. Okay, we have 35.8 grams of this compound. And we would like to know how many grams of chromium. Now, let me set you up why you might want to do this sort of thing. You are a geologist, okay, and you're out looking. Let's just say, this is artificial, but you need a source of chromium because cars use chrome trim and so forth. You want some chromium, and we have to ingest a tiny bit of chromium to stay healthy. Okay, so we have this source, we have this mineral that is ammonium dichromate. We want to know, if we rip it apart totally, how much of the pure chromium metal do we need to get, could we get out of that? So here's what I would recommend. I think this is by far easier than the book. If I can come up with the formula weight, step 1, and then I can come up with what percent is chromium, then in step 3, I can use that percentage and take that percentage of this. You follow that reasoning? Okay, we've got this much of this. We're going to pretend we can totally rip it apart and get at that chromium, purify it, go sell it. Okay, so first, step 1, if we want to go the percent route, step 1, I need a formula weight. And in this compound, I see nitrogen, hydrogen, chromium, and oxygen. Okay, Tran, how many nitrogens do I have? 2. And what contribution does it make? 14.0 for a total of 22. 28. Our hydrogens, Marco, how many?
8.
8, and they make a contribution of
1.
1.0, so they give us a total of 8. Our chromiums right here, Eddie, how many?
2.
2. Each chromium gives us how much? Can you spot chromium up there?
52.
Yeah. 52.0. So 104. Was I okay on the .0? Okay. And then, how many oxygens, Allison, do I have? 7. And what contribution does the oxygen make, Allison? 16.0. Somebody tell me that one.
112.
112? Okay. And then here we are with our bookkeeping, the safe way to go. So Alex, what's our formula weigh? 252.0 grams per mole. Okay, now, that was step 1. Step 2, let's go after percent chromium. So this gives us review of percent composition. So chromium makes this contribution out of the whole. So let's go after percent here. Tanya, how should I set that up?
104.0 divided by 252.0.
Okay, we'll just say that's grams, so that's grams. I want a percentage, so
Multiply times 100.
multiply by 100. Okay, so let's work that out, and let's get our percentage here. Hina, do you have a percent for me?
Oh, sorry, I multiplied that. It's 41.3%.
Okay, let's have one more digit. 3, do you have another
43.27.
27? Okay. We actually wouldn't have to, since this one just has 3. That one's kind of your own call. It's that percent. And so step 3, I got to take this percent of that. So I really made Tanya or somebody do some extra work here. We really don't have to take it by 100, because then we're going to whip it back into decimal form. So we'll have 35.8. And if I want to take this percent of it, what am I going to do, Antonio? Antonio, what am I going to do?
You multiply it.
Okay, by 41.27? It's a trick.
No, by 0.4127.
Perfect, perfect. Now, let's multiply that, and we'll find out. Meredith, how much chromium can we get?
14.8 grams.
14.8 grams, and great, she went back to her 3 cigs here. If you used 41.3 here, you may get just a little bit difference, no sweat. Either way is fine. So that tells us, if we found that much chromium, or pardon me, if we found that much ammonium dichromate, this is how much chromium we could get out of it. And couldn't you take that on? If nitrogen suddenly became very valuable, you could find out how much nitrogen, or any of them, we could get out of it. Okay, so that was section 210. Then, section 211, one last problem here.